Hi, I'm Colleen from Mom Teaches Tech, and I can see you're here to learn today. So I just love that for you. Let's get started. Today, we're going to focus on how routers learn routes dynamically, but not how to configure them. So we're not configuring dynamic routing protocols today, which is actually the fun part. But if you're studying for your Cisco cert, you've got to learn this. So we're going to spend this lesson getting comfortable with the vocabulary and ideas that you'll use when working with dynamic routing protocols. Fun, fun, fun. Everything we're going to talk about in this video lives inside the dynamic routing designation. Hopefully you're in the right spot, but if you've no idea what I'm talking about, you may want to watch some of the prior videos in this routing series. Hopefully by now you've gone and done some static routing configurations. If you have, you've possibly felt the pain of static routing and are most certainly tired of typing in IP route, network I want to go to, subnet mask, next hop, or exit interface over and over and over again in every router. That right there is what's meant by static routing doesn't scale. So if you've completed my static routing challenge packet tracer, you will have entered 3 static routes into each of the 4 routers for a total of 12 entries. Most people make some mistakes as they're doing that along the way, and then, well, you have to troubleshoot and figure out where the error is. This can be very time-consuming and a frustrating experience. Also, every time a new network is added or removed, all of the routers must be configured with the new route. On top of that, if for some reason there's a hardware failure, network traffic is not rerouted automatically and must be fixed manually. This is what is meant by static routing doesn't scale well. It's just too complex to enter all of those routes for every change, and every change requires a human intervention. In essence, configuring a dynamic routing protocol allows routers to learn about networks automatically, rather than relying on a person to manually enter every route. Dynamic routing protocols are designed to handle growth, change, and failures more efficiently than manual routing. The complexity with dynamic routing comes up front when you are learning how the protocols work and how to configure them correctly. But once a dynamic routing protocol is properly configured, it requires far less ongoing maintenance and adapts automatically as the network changes. That's a beautiful thing. The key task for you now is learning all the various routing details unique to each protocol, and then choosing the right dynamic routing protocol for any given network. I'm sure you've gotten the idea by now that dynamic routing protocols do not all work the same way. Of course, that would be easy. And it may feel like acronyms start multiplying like tribbles, which can be a bit overwhelming. The good news is that underneath all those acronyms, there are only 3 basic approaches that routing protocols use to make decisions. The first approach is based on asking neighbors for directions. In this case, a router never knows the full path. It only knows what its neighbor tells it is the best next step. You can think of it like asking for directions on a trip with multiple stops. Your neighbor can only tell you how to get to the first stop. When you get there, you ask again and repeat that process until you reach the destination. The second approach allows routers to build a complete view of the network. Each router sees the full picture and independently decides which path to take. The third approach ignores shortest paths entirely and instead follows rules and policies set by the network administrator. Over the next few slides, we'll break these ideas apart and attach acronyms as we go. I'm going to keep building on this table that I've started here so you can keep the new information sorted in your brain. If you can keep these 3 patterns straight, the terminology becomes much easier to manage. If you're feeling extra ambitious study-wise, you can try and write down the words written in bold that I've indicated on this chart from memory at the end of this video. That is an excellent exercise in memorization and would make me ever so happy. As we build out this chart, we are only going to focus on the first two concepts. Distance vector protocols learn routes by asking their neighbors for directions. Routers do not see the full network. Each router knows how far away a destination is, which neighbor to send traffic to, and routers rely on information received from their neighbors, not a global view. Routing decisions are influenced by neighbor updates, and because routers don't have a full map, convergence can take longer. It's important for you to understand the concept that each router only knows what its neighbors tell it. This is distance vector routing. Examples of distance vector routing are RIP and EIGRP. Distance vector protocols are simple to understand conceptually, but they are limited by their own partial visibility. On the other hand, link state protocols work differently. Routers build a map of the network before choosing a route. Routers share information with each other about the network itself, not just directions to the next hop. Each router builds a link state database, which represents the network topology, and all routers within the same area end up with the same map. Each router independently calculates its best path to a destination, and routing decisions are not based on neighbor opinion, but on their own local calculation. Once the map is built, the router runs the SPF algorithm to determine the best paths. So to sum up the difference between distance vector and link state, distance vector asks its neighbors for directions, and link state builds a map and decides for itself locally which path it's going to take. For the CCNA, you do need to recognize which routing protocols fall under distance vector and which fall under link state. Each protocol does have differences in how paths are determined, but we're going to cover those later when we focus on the protocols individually. For now, your goal is simply to organize the names and acronyms in your head and understand which category they belong to. As you can see, under distance vector, we have two protocols, RIP and EIGRP. You may see older material that mentions IGRP as a distance vector routing protocol as well. IGRP has been depreciated and replaced by EIGRP, which is the protocol you should focus on instead of IGRP. And under link state, there's OSPF and ISIS. Distance vector and link state routing protocols are typically used as interior gateway protocols, or IGPs. An interior gateway protocol is used within a single administrative domain, meaning the network is under the control of one organization. That organization could be a company, a university, a data center, or even an internet service provider within its own internal network. The size or geographic distance of the network does not matter for a protocol to be considered an interior gateway protocol. What matters is who controls that network. IGPs are used for routing inside an organization, not for routing traffic between different organizations on the internet. The final dynamic routing concept we need to introduce is routing based on rules and policies. BGP is the routing protocol used for this purpose. BGP is an exterior gateway protocol, or EGP, which means it is used to exchange routing information between different organizations. Unlike interior gateway protocols, BGP is not focused on finding the shortest path inside a network. Instead, it uses policies and rules to decide which paths are allowed or preferred between networks. This is how routing works across the internet. where many different organizations connect to each other. That's a wrap up of some basic acronyms and terminologies for dynamic routing protocols. As I mentioned earlier, it would be really helpful to your memorization techniques, or what do I want to call them? Well, just your general learning. If you try to write down those words that I mentioned in bold, fill out that chart, see if you can remember how Cisco splits up these dynamic routing protocols. And if you don't do that, I'm going to be very disappointed, but I'm a mom and a teacher, so I'm used to disappointment. Don't worry about it. If you do give it a try, you can post something down in the comments, and I'll try to be better at commenting on people's comments and trying to build this YouTube channel, so that's helpful. I'll give you a well-deserved pat on the back if you decide to do that. I hope this helped you. If it did, we're winning. I'll see you in the next video.